Let us talk about this problem. We are given two strings. We need to check whether these two strings are anagram of each other or not. Two strings are said to be anagram if they have same set of characters. Every character in both these strings has same frequency. Let's understand the problem with these examples. We have two strings. S1 has value listen and S2 has value silent. If you take a look at these strings, every character has same frequency and they both have same set of characters. L appears here, here. I in both these strings, S in both these strings, T in both these strings, E in both these strings, and N also both these strings. And every character appears once in both the strings. So these strings are anagram of each other. Let's now see the second example. A appears 3 times here, A appears 3 times here, B appears once, B appears once, C appears once, C appears once. So they are anagram of each other. Now let's see this example. Here we have one string as ABC and the other string as ABD. So here we have C which is not here, D which is not here. So these two strings are not anagram of each other. Now just to clarify the problem more, if I remove one A from here, then also our answer will become no, right? Because you have A's frequency 3 here and A's frequency 2 here. So if all the characters have the same frequency and both these strings have same set of characters, then we call them anagram. Now please pause this video and try to write down a function that takes two strings as an arguments and returns true if these two strings are anagram of each other, otherwise returns false. Let us talk about method 1 to solve the problem. This method is to sort both these strings and then compare them one by one. If two strings are anagram, they will become same after sorting. So let's understand this problem with this example. So we have two strings, this and this. After sorting, we get the string S1 as this, right? A comes first, then B, then C. And after sorting S2, we also get this. And these two strings are anagram, and after sorting, they become same. So our task is to now compare both the strings one by one. If string 1i is not equal to string 2i, then we return false. And we have an additional check before sorting. The check is if length of string 1 is not equal to length of string 2, then also we return false. This is a basic check for doing some optimizations, for handling some test cases very quickly. If you have two strings of unequal length, you can simply declare they are not anagram because they cannot be anagram. Anagram means mainly requirement is their lengths have to be same. And if lengths are same, then we check if every character has same frequency. And for checking this, we have sorted both the strings first and then we are comparing both the strings one by one. This solution has time complexity big O of n log n, where n is the length of a string. I'm assuming length of both strings is same. And if the length of both strings are not same, then it's obviously big O of 1. Now please pause this video and think of a solution which works in big O of n time. Let us now talk about efficient solution to solve the problem. The idea is to use count array. Let's understand the solution with this example. Let's say we have these two strings. First string is ABA, CB, CC. Second string is CCC, B, AA, B. First thing we do is we count occurrences of all characters in string 1. So we have the count of A as 2, count of B as 2, count of C as 3. So we make an array of size 256 because maximum different possible characters are 256. The character set is 256 in size. So we use these characters as ASCII values and we use these ASCII values as indexes, and that's how we find the count of every character in an array of size 256. So small a has ASCII value 97 and its count is presented index 97. So we initialize a count array as 0, then we traverse through the string 1 and increment the counts. So this is how we get the count of A as 2, count of B as 2 and count of C as 3. Now we traverse through string 2, right? And this time instead of incrementing the count, we decrement the count of characters which are present in string 2, right? So we traverse through string 2 and C appears 3 times. So we are going to decrement this count by 3. We are going to get 0 here. This appears 2 times. We are going to decrement the count by 2. We are going to get 0 here. And then A appears 2 times. So we are going to decrement the count by 2 and we are going to get 0 here. After we processed string 2, and if these two strings are anagram of each other, then you will have finally count array as 0. That's the check we are going to make. So first we traverse the string 1, we increment the counts, then we traverse the string 2, we decrement the counts, and at the end we check whether this count array has all values 0 or not. If this count array has all values 0, then we say S1 and S2 are anagram. Let's modify the example slightly. Let's say we had a B here. So what will happen in this case? The count of B is 3. So we will have 3 here, and count of C is 2. So we'll have 2 here. Now we'll traverse through string 2, and A's count will become 0, but B's count will become 1, and its count will become -1 because C is here 3 times. So we do not have all values in this count array as 0. It means these strings are not anagram. So this is the idea. You traverse through both the strings one by one. You increment the count for every character present in string 1. You use characters as indexes in this count array. Then you traverse through string 2 and you use characters as indexes and decrement the count. And then you traverse through this count array of size 256 and you check if all values are 0 or not. If all values are 0, then you return true. If you find a value which is non-zero while traversing, you return false immediately. So this solution requires big O of n time, right? I'm assuming n1 and n2 both are same and they are equal to n. If they're not same, then it's big O of 1, right? Because we simply check this thing as a first thing in the program. So this is an efficient solution, linear time solution. If you talk about auxiliary space, then you can say it's constant because the alphabet size is constant. It's 256 only. In general, we can say its auxiliary space is big O of alphabet size. Now, few remarks about this implementation. This implementation can be slightly optimized if you talk about C++ programming language specific things. We can pass these strings as references. This way, when somebody passes two strings as arguments, they're not copied, right? That will save some extra copying time. So this is one remark. The thing with adding references is this: when you add reference to a function, this allows this function to modify the strings also, right? This may be a function of some library or some third-party function that you are calling. So when you are passing strings as references for only efficiency purposes, not for modifications to these strings, what you do is you pass those strings as constant references. So the best programming practice here is to add a const here also. So we pass const string ampersand. This will have efficiency, and this will also ensure that this function does not modify the strings because its target is to just check whether two strings are anagram or not.